All right, so today we are moving along. We're still dealing with trigonometry, but like I said last week, we are now looking at trigonometry without having a right triangle. Okay, everything that we've learned so far, sine, cosine, tangent, we apply to right triangles because that works nicely. But luckily for us, or unluckily, depending on how you feel about trig, we can apply rules of trigonometry to what are called oblique triangles. Okay, an oblique triangle is any triangle that does not have a right angle. So it is either a right triangle or it is oblique. Now we do have other ways of naming triangles, right? We have scalene, which means none of the sides are congruent. We have isosceles, which means we have two congruent sides. We have equilateral. Yeah, equilateral, which means all the sides are equal. We have acute, which means all the angles are acute. We have obtuse, which means that one of the angles is obtuse. We have a lot of different classifications. But this is just oblique triangles, so it's a kind of general, anything that's not a right triangle. Right, so the triangle is set up like we are used to seeing. All right, so we have our three angles. We use our capital letters for the angles, A, B, and C. And we have our three sides where we use lowercase letters. And I'm pretty sure we talked about this before, but remember the name is opposite of this angle and side. Okay, so because this is angle A down here, if I go across, that is side A. Angle B is down here, I go across, that is side B. Angle C is up here, and you go across to the bottom to side C. All right, so if we have two specific situations, if we either know two of the angles and any side, which would give us angle, angle, side, or angle, side, angle. I know you thought you were done with these. And we're not doing proofs like, we did back in geometry with angle, side, angle, and all that stuff. This is just different ways to classify the information that's given to us. So if we're given two angles and any side, or two sides and an angle that's opposite, so side, side, angle, then we can use what's called the law of sines to solve the triangle, which again means to find any and all missing pieces of the triangle. All right, so just notice too, we need to know at least three things, which means that we'll be finding out three other things. All right, so that's kind of how it works. You're given three parts, and you have to find the other three parts. All right, we will go over the different, two other situations, but for now we're just looking at these two. So the law of sines tells us that we can set up equivalent proportions or ratios to solve for what's missing. So here you have A over sine of A equals B over sine of B equals C over sine of C. Now this is a little confusing because we have two equal signs and we got three parts, but we're never using more than two at the same time. Right? So, I might have angle A and side A and side B, and I'm looking for angle B, so I would use the first two parts and I wouldn't worry about that third part. Okay? Or if I had angle A and side A and part of C, all right, I would skip the middle part and I just use the outer parts. So you're not going to use all three at once, right? But do know that you can use any combination of those. You can also flip them around. So you can have the sine of A over A is equal to the sine of B over B equal to sine of C over C. Okay, it doesn't matter the order because that's how proportions work. That's how ratios work. Usually we'll stick with this way though. All right, so let's take a look at an example. We want to solve the triangle below. Right, again, and that just means we're looking for all the missing pieces. So my first recommendation is to write down what we do know. Okay, organize the information into what we have and what we're looking for. So here, right, they tell us angle B is 29 degrees. They tell us angle C is 102 degrees. And they tell us one of the sides, because it's across from angle B, that would be side B, equals 28, whatever it is, feet, inches, centimeters. So that means we're looking for angle A, and side C. So what's nice about this is usually there's more than one starting point. There's more than one thing that you can find out first. So from our ratios, okay, we're gonna look for a variable that we know both the side and the angle for, right? Because that's gonna help us. So here, B, we're probably gonna use B with our equations, with our law of sines, right? Because again, we know both the angle and the side. So I could go ahead and I can set up my law of sines using the B and the C portion, right? Because I have both parts of B, I have the angle of C, I'm looking for the side of C. So looking for a lowercase c, right? First, for now, I'm just gonna write down what I'm using and then I'm gonna plug in. Again, as you become more comfortable with the process, you can skip this first step. So I'm just gonna write B over sine of B equals C over sine of C. All right, so that's the variables I'm going to use. Those are the parts we're going to use. So now we're going to plug in 28 over the sine of 29 equals C, since that's what we're looking for. You could put X there, you could put whatever. I'd like to keep the C though. Sine of 102. Right. After we get it set up, then all we got to do is solve. Right. So in order to solve for a proportion problem like this, we use some cross multiplication. I will give you a hint though. Do not calculate the signs until your last step. Okay, don't do any calculations, don't find any decimals until you're ready to plug everything into the calculator itself. All right, because if I round, that might change my answer. Okay, and I'll show you at the end of step C how we can get a different answer. So we're going to cross multiply, so I get 28 times the sine of 102 is equal to C times the sine of 29. And then if I wanted to solve for C, okay, because I'm multiplying, I would divide. So I have C is equal to 28 times the sine of 102 over the sine of 29. Now this is what I would plug into my calculator. This is what I'd punch in. So let's do that. So we get, well, first let me make sure. We are in degree mode. Okay, so again, always make sure you're in degree mode if you're dealing with degrees. Otherwise, your answer will be way off. So I'm going to have, I'm going to put in parentheses 28 times the sine of 102, close my parentheses twice, divided by the sine of 29. So we get side C is 56. We'll say 56.5. And that kind of makes sense. It looks like it's going to be the largest side, so obviously it's going to be larger than AC. Right, so that's okay. Now, couple of disclaimers. If you are using your phone then you might have to do some rounding. Okay, I don't think you can type all this in at one time, but I don't know. I'm not sure. If you're using a program like Wolfram Alpha or Symbolab, then this is okay, but be careful. So let's take a quick look before we continue at what happens if I rounded these. So let's say I calculated these. I'll do it over here in the margin, really tiny. So if I say the sine of 29, all right, so say here I just said that this was 0.5. So I put 0.5 here. And then I'm going to do the sine of 102. And that's close. So that almost looks like a 1, right? If I used rounding to 1 decimal place, I'd have to bump that up to a 1. So let's say it is 1. Actually, let's even just say 0.98. When I do the cross multiplication here, I do 28 times 0.98 divided by 0.5, and I get 54.8, which is kind of close to 56.5. But, you know, if you're trying to build a space shuttle and you came up with this and you're supposed to get that, well, then your space shuttle is probably going to blow up or something. All right. So hold off the rounding until the end to be more accurate. All right, so just be careful there. I just wanted to show you that. So we found C, so I'm going to replace this with 56.5. All right, so now we encounter somewhat of an issue. I don't know anything for A. So even if I set up a proportion, if I set up anything, you know, here, I don't have anything to plug in, right? I wouldn't have A or sine of A. And I can't set up a proportion with 2 variables. It's impossible to solve. But luckily, we do have some other tools at our disposal. I can find angle A because we're dealing with a triangle. Right? So I can subtract 102 and 29 from 180 degrees. I'm going to do 180 minus 102 plus, what was that, 29. So my missing angle is 49 degrees. So if you're given 2 angles, then luckily you can use basic geometry to find the third. Now that we have that, okay, we can set up our proportion. I've mentioned this before. I'm going to stick with the B's because that was given information. Okay, I may have made a mistake and miscalculated my side C, so I don't want to use this proportion to find A, just in case I made a mistake. Maybe I was in radians, maybe I rounded wrong. Okay, right, maybe I did this way and I got 54 instead of 56. That's going to change this answer. So I'm going to stick with the given information, which was the B. And I'm pretty certain about A because hopefully I didn't mess up basic subtraction. Right, so again, you don't have to write it out like this if you feel comfortable with it. I'm just doing this for the setup. So your B is going to be the same, 28 over the sine of 29. And that is now going to equal A over the sine of 49. So I'm going to have room. A equals 28 sine 49 all over the sine of 29. And this is what we can type in. Let me see real quick. Here's mine. I want to see how this looks. Now, I know most of you probably have iPhones or Androids, which are different than what I have. So your calculator will be different. Because here, luckily, I do have sine, cosine, and tangent. Right here, most of you don't have it in this form. You probably have to turn it into landscape form. Okay, again, always make sure that tells me I'm in radians. I want to check I'm in degrees. So let me just see how it works out this way. So let me do 28 sine of 49, close parentheses, divided by sine of 29. Okay, that works like that. We got 43.6, we'll say. All right. Again, I know, I don't know if they changed it, but when I did have the iPhone, if I wanted to calculate the sine of 102, I couldn't hit sine of 102. It wouldn't show up like this on the iPhone back, again, I'm dating myself, but back in the day when I had like an iPhone 6. You'd have to do 102 and then hit sine, and it would do the calculation. So just be really careful if you're using your phone for that. Again, I would use, they have an app, Wolfram Alpha. All right. You could type everything in right here. So I could do 28 sine of 49, close parentheses, divided by the sine of 29, and there we get, right, 43.6, 43.6. All right, so you have a few different ways if you don't have, a calculator with you. And I'll just put that rest of the information in here. So this was 49 degrees, and this was 43.6. Any questions with the process of law of sines?
No.
Okay, so one last thing that I want to talk about for today is a way to kind of check your answers without doing intense math. So we came up with all of our, all the missing pieces. So what's nice about triangles is the relationship between angles and their opposite sides. With triangles, the largest angle is going to be opposite of your largest side, right? And it kind of makes sense geometrically. If I have a really small opening and I connect, if I have a really small angle, really small opening, and I connect the two lines, it's going to be a really small line that connects them. If I make a wider angle, the connection is going to be longer, right? That's just kind of how math works. So as long as your sides match up with your angles, then you're probably okay. All right, so 102 is my largest angle that I have. So it should be across from my largest side. And that is true. 56 is larger than those two. My smallest angle, 29 degrees, should be across from my smallest side, 28 there. Right? That's my smallest side, smallest angle. And then the middle should be in the middle. All right, so that's just kind of a way you can kind of just look at it without doing, like I said, any more crazy math to see if you're in the general ballpark. Now, unfortunately, if you do mess up, if you were accidentally calculating in radians, or if you rounded wrong, you still might end up, with that same situation. But it's a good kind of way just to say at the end, all right, let me double check. Smallest side, smallest angle. Largest side, largest angle. All right. Okay. Tonight, I would like you to try one of these. So I'm going to give you a triangle, and you're going to find the missing parts. All right, so it'll be set up like this, where you're given 2 angles and a side. And tomorrow we'll take a look at our other instance that I told you about. 2 sides and an angle. All right, it's a little different process that we have to do there, and we have to. There might be more than one solution to that problem, so we'll need some time to dive into that. All right, guys. Keep an eye out for the assignment. Have a good day, and I'll see you all tomorrow.
Bye, Mr. Murray.
Bye.
Bye-bye.